Hello everybody. In this video we're going to be covering one of the sections in chapter 5 of our text, molecules and compounds. The first thing that I want to cover is what exactly is the distinction between molecules and compounds and the atoms and elements that we learned about before. So if we think about the entire world and everything that's in it, we definitely can't just be limited to the elements, right? There's only like so many of those, and we see a lot of different things, right? And if we think of something like salt, we know that this is sodium chloride. So it's made out of sodium, and if we get a picture of sodium, it's a metal, it's reactive, it's poisonous, okay? And if we think of chlorine, well, this is like a toxic gas that we can only trap in like a flask or something like that, and it's also poisonous. Yet for some reason, when we combine them together, we get sodium chloride, which is our table salt, which is something important for us to eat, right? And has very different properties than sodium or chlorine. And another one that we could think about would be like sugar. So this has carbon in it, hydrogen, and oxygen. Each of these is very different things, and gases and stuff. And yet when we combine them together, we get this white crystalline sugar. So basically, the moral of the story is that when we combine elements together to make molecules, we wind up with compounds that have very different properties than the elements that make it up. Okay, and that infinite amount of combinations we can do to make all the molecules and therefore the various different compounds that we're going to get out of it is why we see all the different things in our world. In this video, we're going to talk a little bit about material classifications. We already made a distinction between elements and compounds in the last chapter. In this chapter, we're going to break this down into some smaller groups and be a little bit more specific. First, we have the elements that we've been thinking about so far, the atomic elements. These are elements whose particles are single atoms. Next, we're going to have our molecular elements, and these are new to us now. So these are elements whose particles are multi-atom molecules. So it just happens to be that some of the elements actually like to bind to each other and form actual molecules. Then we're going to have molecular compounds. These are compounds whose particles are molecules made of only nonmetals. So we only have different nonmetals bound together to form little molecules. Water is an example of that. And then we have our ionic compounds. These are compounds whose particles are cations and anions. And what actually winds up happening is they're not really discrete molecules. They're actually more of a continuum. And we just really talk about the basic repeating unit of it. So molecular elements. These are certain elements that occur as diatomic molecules usually, where they like to bind to each other and make these little molecules. In order to identify which of the elements are going to want to be diatomics, we have this thing called the rule of sevens. We start by finding the element with the atomic number of 7. That would be nitrogen on the periodic table. Then we're going to make a figure 7 by going over to group 17 and then down. And then finally, the 7th element that's going to be our 7 is going to be H2. And we get all of the diatomics that like to be formed. That includes all the halogens, O2, N2, and hydrogen. Molecular compounds can be identified when you have 2 or more nonmetals. And the smallest unit is going to be a molecule. So you need 2 nonmetals that are or more that are bound to each other. So they got to be of different sorts. Otherwise, they would be molecular elements. And we're going to have these little molecules that are going to fit together. Ionic compounds are going to be indicated when you have metals bound to non-metals. You're going to have no individual molecular units. Instead, you have this three-dimensional array of cations and anions made of what we call formula units. So if you looked at salt really carefully, you're actually going to see that it's just sodium and chloride ions, one right after another, always bound tightly together, going on for what seems like infinity because these atoms are really small compared to the overall bulk. But to describe them, we only talk about the smallest repeating unit, which would be one sodium and one chlorine atom in this case. And that's what we call our formula unit. And here's the molecular view of the elements and compounds. So we've been breaking this down a little bit more now. So now we have pure substances. They can come in the form of elements or compounds. We can have atomic elements, or we can have molecular elements, and we can have molecular compounds, or we can have ionic compounds. Let's do a little practice here and see if we can identify some of these. So if we have aluminum, just a single Al, we can have aluminum chloride, chlorine as a Cl2 molecule, acetone, carbon monoxide, and cobalt. See if you can classify each one of these. So aluminum all by itself is going to be an atomic element. It is not forming a molecule, and there's only one type of atom present. Aluminum chloride is going to be an ionic compound because we have a metal and we have a non-metal that are bound together. Chlorine, Cl2, is going to be a molecular element because it's forming that diatomic. It's one of our 7 diatomics. Acetone is going to be a molecular compound. There's no metals in here, but there are different types of elements that are bound together. And carbon monoxide is also going to be a molecular compound because, again, we have no metals and we have 2 nonmetals bound together. And finally, we have cobalt, which is going to be an atomic element because, again, we only have one type of element and it's not binding to itself.